Can I start?
Yep.
Okay. Good morning, everyone. Today I'm going to present Trading for the Future, a very important paper by Arstad and Escalon. The focus of the paper is on inefficient outcomes that may arise in permits market because of both firms and institutions' behavior. Author says that there could be distortion even larger than the gain from trade, making the market itself highly inefficient. Although permits are applied in a lot of fields, from carbon emission to fish catch, their history is very brief. So at the time of writing, there weren't many data available, and the previous work were based mostly on experiments and simulations. But anyway, they suggest that the gain from trade was huge. So at the time, many economists started comparing taxes with tradable permits in terms of efficiency. Tradable permits has a big advantage. Permits market are supposed to combine three very important social objectives: efficiency, redistribution, and environmental goals. Let's say that the mechanism behind is very simple, because the government periodically, let's say every 3 or 5 years, that's how it really works, intervenes redistributing quotas, permits among firms operating in the market. The permits are distributed as quotas as a share of a target level of pollution. The firms with the high cost of cleaning pollution are beneficial with more quotas. So, but do permits really work in a dynamic setting? After this overview, this preliminary information, this is how we're going to move throughout the rest of the presentation for analyzing the core models of the paper. Before entering any models, we're going to explore the idea of signaling, which is crucial for understanding the paper, and it's also very relevant in economic studies because very applied. Then we're going to set our static model, which we're going to use as a benchmark for our results. We're going to implement it in a dynamic version with new features in order to add more realism to our analysis. We then compute the equilibrium, and at the end we collect results and discuss briefly the conclusions. So, what is signaling? Well, the idea of signaling considers two parties playing different roles in a framework of incomplete information. One of the parties is called the agent in the literature, and the other the principal. And we consider that the agent has a lot of interest in sending information about its type, about its nature, to the principal through signaling. On the other side, the principal can only observe signals and make beliefs on the signals. And then, based on his beliefs, he will take future actions, future choices. We will see how, in the model of the paper, the role of the principal will be played by the government, the agent will be the firms, and the emission level will act as a signaling activity. So the static model starts with government distributing quotas to a very large number of firms. Each firm maximizes its profit by choosing an emissions level, Xi. Firms in the static model can be of two types: low-cost firm and high-cost firm. This is obviously private value, and the government doesn't already know it. So we should start our analysis considering that if there were no restriction, if there were no need of quotas, then each firm would maximize its profit, setting its marginal cost equals to zero. As simple as that. That means that each theta I will be equal to xi. But if we want to reach a socially optimal solution, we should consider also a positive parameter V, which represents the marginal value, social value of reducing pollution. Then the function to be optimized will be this one, which is nothing more than the profit function of the firm minus V times the emissions level. Given the quotas distributed by the government, we know that an equilibrium will be reached when each firm will set its marginal cost equal to the price of the permits, so the price of the quotas here. This equilibrium will imply a first best equilibrium, and so the market here reached the top of the efficiency. This, by the way, is the condition that we have to keep in mind as a benchmark. If we want to implement the model in a dynamic version, we need some element to be added. First of all, we have to consider an infinite number of periods, each one with a discount rate. Then we need a probability distribution about firms types across the periods here. But author says that we are looking for, in this dynamic setting, for a perfect Bayesian equilibrium. Then, for finding a solution, we need a tool that in the literature is called the intuitive criterion. This intuitive criterion helps us ruling out all the non-profitable strategies for the firms, implying that the equilibrium will be unique and in separated strategy. So the government at the end of each period observed the price of the permits and the emissions level and tried to learn something more, try to make a belief upon firms' types. And so it starts the next period distributing more quotas to the firms that have polluted more because they should have higher cost of cleaning pollution. The point is that also low-cost firms have interest in receiving more quotas in the next period. So they could be tempted to imitate high-cost firm strategy by polluting more. This makes high-cost firm polluting more too, because high-cost firm then needs to separate themselves from low-cost types. They have to separate again. Now the high-cost firm strategy turns into polluting more than was optimal, reaching an emission level that by the intuitive criterion is not feasible, is not affordable for low-cost firm because it's too costly. Indeed, these are the dynamic setting equilibrium condition, and as you may have already noticed, the high-cost firm level of emission now depends also on a variable R, which is the reputational value. Reputational value enters the price function. It is a component of the price. So it is easy to see that when the reputational value equals 0, the market is at its first best level, and the equilibrium conditions are the same of the static model. But R can be also positive, okay? So when R is positive, the price is higher than the first best level, and then this changes our equilibrium condition, generating inefficiency. The value of the reputational value relies completely on this inequality. As you can see, I'll take a little step behind. You see, this is R, this is the reputational value, and we take the element into parentheses here, and we generate this little inequality, whose members are nothing more than the cost and the revenue that the low-cost firm will face if it decided to imitate the high-cost firms. then it's easy to see that when costs are greater than revenues, the reputational values is just equal to zero, and so no distortion occurs in the market. While on the opposite side, when revenues are greater than costs, the reputational value must be higher than zero, must be positive, and then price increase, and firms act differently. This is the core of the dynamic setting model and can be represented in this graph, where on vertical axis we have the marginal cost function of the two firms. We have both types, the high cost types on the right hand side and low cost types on the left hand side, while on the horizontal axis we got both quotas and pollution level. So if we start by a uniform quotas distribution, because you see here the length of the two quotas is the same, and the quotas are tradable, where they are supposed to be, firms start trading and they start polluting, and they reach the first best where the two marginal cost functions intersect, exploiting all the economic potential of the market, generating the so-called gain from trade represented by this triangle B. But the point here is that the reputational value is not equal to zero, and then price is not at its best level. As you may see here, price is actually higher because the reputational value is positive. So what happened here? Well, the high-cost firm buy more permits and they pollute more. In fact, their pollution level is far from the optimal one. On the other hand, low-cost firm will sell more permits and they will pollute less. This is obviously an inefficient allocation by definition, and the social loss they have generated in this scenario is represented by the triangle A, area A, whose existence by itself is not enough in order to prohibit permits to be tradable, but when A is greater than B, so once the social loss is greater than the gain from trade, we know for sure that the market is completely inefficient. Collecting these ideas of the core models, we can plot this graph. We can draw upward sloping indifference curve in this plane, where on the x-axis we have the marginal social value of reducing pollution, where on the y-axis we got t, the time interval between government intervention and the other. And then we can recognize four portions of the plane corresponding to a related level of inefficiency of the market. And then we can start, we can pick, let's say, a time of 3 years here, and then we can make V increasing, we can make the social marginal value increasing, and we can pass from the portion number 1, when the market is completely efficient, moving progressively toward the portion 4, when the market is not efficient at all. I will conclude reflecting, thinking on how our economic thoughts are deeply based on fundamental welfare theorem. In particularly the second one, that suggests that a mix between market and governments is the best solution. But authors here, and I guess that this is the novelty, here realize the importance of the paper, have shown that in a dynamic setting, sometimes the best solution is extreme. Complete free market or no market at all. Thank you for the time. Any question?
I wanted to ask you if you could just repeat the intuitive criterion.
Yeah, sure.
Thank you.
Okay, here it is. So there's an entire paper on this by Sean Krebs, 1987. I get to read it because it's a very tough idea. But roughly speaking, it says that if if the government observe, let's say, pollution level X prime, and government knows that this can never be optimal for a low-cost firm, then the government must conclude that the firm in that case is an high-cost one. Okay. As I was saying before, these rule out non-optimal profitable firm strategies and doesn't allow for a pooling equilibrium to be, because with this setting, if we get an optimal unique pollution level, it would imply that we got a unique type. But here, with different type, we must have a separating strategy. Thank you.
Okay. The question, thank you very much.
You're welcome.